The cost of tuition at Carson University was $23,300 for the 2013-2014 academic year at Carson University. My alma mater, and that number is accurate for this past school year. If tuition increases at a rate of 3.5% per year, how much will tuition be in 13 years? I've also included the interest formula for you there. The amount is equal to the principal being the starting amount, times 1 plus your rate to the t power, which is time in years. Okay. If I'm going to solve this using a recursion, we're more comfortable with recursion, so let's start there. What I'm going to want to do is in box A1 calculate what tuition will be in one more year. So after 1 year, what will tuition be? Or what will it be in the 2014-2015 year? So what we want to do to calculate that is take the current tuition, and we're going to multiply it by 1 plus our increase. We want our increase to be represented as a decimal, so convert 3.5% to 0.035. And we do 1 plus 0.035 because we want to calculate 103.5% of the tuition. And that gives us 23,805. So that is that increase. If I want this to continue into the second year, all I need to do is tell Calc to grab the value from box A1, which is our tuition after 1 year, and again do a 3.5% increase of that value. Okay. So this now represents how much tuition will be after 2 years. If we copy and paste this formula, Calc will automatically update it to the correct boxes, and we can find the tuition as it increases throughout time. Okay. Any given box gives you its formula up here. So box A17 is found by multiplying cell A16 times 1.035, which gives us our tuition. If we want to know the tuition after 13 years, since we started with in cell A1 after 1 year, cell A13 will have after 13 years, which is $35,970.99. Let's do it with the formula as well. Let's do it with a function. Okay? There are values of being able to do it with a function, especially if you're going to work this out on paper. You're going to want to use the function instead of a recursion. If we want to use the function, we need to tell cell B1 to apply our formula. So we start with the principal, $23,000. Okay. We're going to multiply it by 1 plus our rate, 0.035. Now we want to raise this to the t power. And t stands for the number of years. So what we want to be able to do is we want cell B1 to multiply or to raise this to the first power. What is it after 1 year? But we want cell B2 to do this to the second power, and cell 3 to the third power, cell 4 to the fourth power. So the way that we can do this is we can tell this box to raise it to a power and then create another sequence that counts by ones. So let's come over to box C1. Now this value is the correct value, but we got to fix our formula. C1, we're just going to make 1 because we want this to be our number of years. Okay. C2 then, we want to do C1 plus 1. That gives us 2. If we copy and paste this formula into the other boxes will count by ones. The value of this when using the formula is now I can tell my formula to raise this rate to a number of years, and I can call upon column C to represent my number of years. So for this box, I want to raise it to the first power, or C1. If we copy and paste that into the next box, we'll see that it raised it to the C2 power, which is 2 years. And then we raise it to the C3 power, which is 3 years. And so we can copy and paste this formula into the remaining boxes, and we can just check to see that all of our values are in fact the same. We found the tuition of Carson Newman University after 13 years using both a recursion in column A and using the interest function in column B.